When we were looking at the structure of dimethylbenzene, which is also known as xylene, initially I was generic where I put the second methyl group. But what you might recognize, or hopefully recognize, is that there's 3 potential places to put that methyl group. We could put it right here. We could put it right here. And we could put it at the bottom. And you should recognize that this carbon is equivalent to the one on the left. Likewise, this carbon is equivalent to the one on the left. So it doesn't matter which side you put it on, it's the same compound. Now, in terms of numbering, if we start at the top, we can designate these in terms of numbers. So this could be considered 1,2-dimethylbenzene, or we could say 1,2-xylene, to use the common name. Likewise, 1,3 and 1,4. That is one way to differentiate these. But there's another type of terminology that's very commonly used to describe the relationship between 2 substituents. And that is the ortho, meta, and para terminology. And effectively, ortho is just a 1-2 relationship. Meta is 1-3. Para is 1-4. And relative to this position, where the R group is at, whatever that might be, we would consider these 2 positions ortho. We would consider these 2 positions meta. And then the position at the bottom of the ring, that is the para position. We can use these terms within the IUPAC names. So coming back up to 1,2-xylene. Because of that relationship, the 2 methyls are ortho to one another. So it would also be totally valid to write this as orthoxylene. Or simply O-xylene. Likewise, the next one down could be meta or M. And then the last one is paraxylene or P. When using these terms or even the numbers, you separate the terms with a hyphen. Let's just look at some compound here with 3 substituents. Now, I wouldn't use the ortho-meta-para terms in the IUPAC name for this because that can start to get confusing. We typically stick with these terms in names with just disubstituted compounds. But nonetheless, if you're just discussing a compound, you can use these terms to refer to relative positioning. For example, you could say the OH and the methyl are meta to one another. You could say the OH and the chlorine are para to one another. And you can say the methyl and the chlorine, those are ortho to one another. So those terms are fine to use when describing the relationship between groups on an aromatic ring. Okay, now one thing I should note, you can't use this for cyclohexane. Don't get those confused. Cyclohexane's a 6-membered ring, but it's not an aromatic ring. It's not a benzene ring.